Alright, so we are going to look at the first type of substitution reaction, where we start with alkanes. Okay. Sorry, the full name here, I see I did not put it in there. The full name there is the halogenation. Halogenation. So the process of halogens. Halogenation of alkanes. The halogenation of alkanes. Okay, so in your head you think halogenation of alkanes. So I start with an alkane and I form a halogen. Right? Okay, so let's say there we have, you can see, I'm going to read this just now. You can see there we start with methane. Okay, how do I know? So I want you to draw it. Okay, how do I know it's methane? Because meth, it is one carbon, and because single bonds, it's not a side chain. Okay, methane, and now it's going to react with chlorine. Now this is actually a type of photosynthesis process. Photosynthesis is where you form chlorophyll, right? Okay, chlorine, chlorophyll. Okay, so when you take an alkane or a haloalkane, not a haloalkane, hydrocarbon, and you add chlorine to it. Okay, so chlorine is a diatomic molecule. Now, when the process of photosynthesis happens, does someone stand there with like a flame or something for it to happen? No. Where does it get its energy from? From the sun. Okay, so that is why we say sunlight. So sunlight there is not the dishwash liquid. Alright, the sunlight here is the energy from the sun. So if the sun doesn't shine, the plants turn yellow, right? Or whitish. Okay, so you can see there, alkanes, a hydrogen is replaced with a halogen. So one of the hydrogens will be replaced with a halogen to form haloalkanes. And the energy here is normally sunlight. Okay, so it requires energy, but this energy is a natural type of energy. Okay, so one of the conditions is that we must have energy, but it can be sunlight. So the way we write this, or we show this, is underneath the arrow, you write sunlight. Okay, so it's not a concentrated high flame or something like that, just mild sun. Okay, so what will happen here is one of the hydrogens will be replaced, substituted with a chlorine. So they will substitute, they will change. Okay, then we have that, and now we have a chlorine, and then we have HCl. Okay. So that is the first type of substitution reaction. It's the halogenation of alkanes. Halogenation of alkanes. I just want to say I did not give you anything on the following pages that are not very important for you to know. Like you need to know this is endothermic. You need to know that it needs energy. You need to know the halogenation of alkanes. Okay, so there's nothing on here that you do not need. Alright. Then this thing, ClCl, is called chlorine gas. Chlorine gas. Cl2 is a diatomic molecule. Chlorine gas. Okay, then questions. Declan, let's start with you today. What is the name of the inorganic compound or product that forms? Okay, let's take it out. What is the name? Check, you know what name is. Of the inorganic product that forms. Okay, so product, which side of the arrow is that? Okay, so we have reagents or reactants, and we have products. You need to know which one is where. Okay, and then the inorganic. So not the organic, what's the inorganic? What is organic?
Organic, not good. Organic food.
No, my first sentence in this chapter. It says organic means it contains carbon. Inorganic means it does not contain carbon. Okay? So my question to you, what is the name of the inorganic compound that forms? Yeah! Right! So one of these two. Which one is the inorganic one? What's his name? Almost hydrochloric acid. Yep. You know this, HCl. Yes? You studied the list in grade 10 and grade 11. Alright, then tell me, what is the name of the organic product? No, man, you know this. You don't even need to highlight. How many carbons is there? One. Eight. Near? Chlorine and side chain. We don't call it chlorine. Chloro. Easy peasy. Okay. Right, next one. Hydrolysis. Hydrolysis. That sounds like what? Water. Ne? Hydrolysis, water. So let's see what happens here. They say hydrolysis is where you take a haloalkane. Now, here is reaction conditions that you need to know. A haloalkane dissolved in alcohol. I told you substitution reactions mild. Everything can't be concentrated. So it's not just a haloalkane, it's dissolved in alcohol so that it's more diluted. Okay, dissolved in alcohol, undergoes substitution reaction with strong bases, but wait, dissolved in water. Okay, so it can't be too strong. We don't want the base to be too strong and burn the compound. Dissolved in water, or just water, and mild heat. So we're going to heat it up. Why? To break those single bonds, to break the sigma bonds, but mild. And they form alcohols. Okay, so let's look there at the first one. Okay, you can see there it has 2 carbons and then a bromo. So 1, 2. This one has 1, 2, 3 hydrogens. This one has 2 hydrogens. And then a bromo reacts with, okay, now you can see potassium hydroxide. Now you need to know what is a strong base. How do we know this is a strong base? We studied this last year. The OH. Okay? We said if anything is an OH, it's most likely a strong bond, especially if it's group 1 or group 2 elements bonded to OH. Okay. Now the ones we normally use is lithium hydroxide, potassium hydroxide, and sodium hydroxide. Those ones they use most often in this chapter. So they are all strong bases. Okie dokie. Alright, so we take the strong base, but we do not want it to burn the product. We want a substitution. It must be mild. Okay, that is why it says aqueous. Aqueous means dissolved in water. So that's why we have aqueous there, because it means water is present. Right. Then we have a few reaction conditions. Okay, except for the fact that there's an alcohol, not an alcohol, a strong base dissolved in water. We must also have, now the normal alcohol that they use there is ethanol, or you can just say alcohol. So this whole process must happen in a container of alcohol. And then mild heat. Triangle means heat. Okay, so you cannot just say heat, it must be mild heat. Alright, we will go on in the next one.